All right, hey there, guys. Today we're going to look at transformations of linear equations. Now, this is a pretty tricky thing for us to look at. Remember, a transformation can be a slide, meaning it can go up or down, left or right. There are different transformations, such as stretches and compressions and reflections. Today's main focus, though, is going to be the slides. But before we start, today we're going to talk about what a parent function is. In this case, a parent function is f of x equals x, or we could even say y equals x, where our slope is 1 and the y-intercept is located at 0, 0. So this is like the most basic equation there is. So I guess is the basic function in a family of functions. So in this case, the parent function would look like this. Of course, it is a straight line with a slope of 1, passes through the origin, a direct variation, proportional, all of those fun things. So I'm going to start by showing you on Desmos how we can graph these equations and what happens to them as we graph them. So I'm going to start with my parent function, which is y equals x. So there's my parent function. Now what we're going to do is graph y equals x plus 1. Notice how the graph changed. So in this case, we added 1. So what ended up happening is we shifted this graph up 1 unit. So this would be up 1. You may want to sketch these graphs if you need to, or snap a screenshot or picture or something so you have a reference for this. So if adding 1 shifted the graph up 1, what do you think is going to happen when we subtract 4? Oops. Y equals x. That's right. It shifted down 4 from the parent function. So this is a down 4. And it would help if I put an N. I knew that looked funny. So that's down 4. So adding and subtracting shifts up or down. So this is a translation. So adding and subtracting is up and down. And in this case, this changes the y-intercept. So the y is what is affected here. Okay. So now let's look at a different perspective. Now this is where we have f of x. So in this case, we have f of x equals negative 2x plus 1. So let's graph this guy. Remember, f of x is y, so I could put y equals negative 2x plus 1. And there it is graphed. So what we're going to do is talk about how it's affecting this next graph. So here we're going to add 2 basically to the entire expression. So what's going to happen is we're going to take f of x, just like we have in the past. So we're going to take whatever f of x was, which was negative 2x plus 1, and we're going to add 2. So now we're going to be left with negative 2x plus 3. So because of this value, we're adding 2. That means we should be seeing a shift of this graph going up 2 units from this original y-intercept. So it would be up 1, 2. So let's see what happens. So y equals negative 2 x plus 3. And there it is, just as suspected. So in this case, we would say that this is up, not 3, sorry, up 2 units. All right, here's another one. Now, most of you can probably see what's going to happen here, the difference. So this piece right here is going to make a change for us. So I'm going to start by graphing the original function, which would be y equals x minus 2. So that means this graph, if we do it correctly, should be shifting down 3 units. So 1, 2, 3. So we should have a y-intercept at -5. So let's see what happens. So I'm going to take my f of x, which is x minus 2, and I'm going to subtract 3. So this becomes x minus 5. So when I go to graph this, y equals, there it is, right through that -5. Of course, I accidentally shifted the graph a little bit. And there it is. So you can see here, in this case, once again, we went down 3 units. So it's a translation down. This is something you're going to need. From now on, I will be putting a password in for your assignments. So in this case, your password for tomorrow's assignment is SHIFT, S-H-I-F-T, all lowercase, no capital letters, S-H-I-F-T. All right, now these are where it gets a little bit tricky. Because there's parentheses involved, this means it's opposite of what you think. You know, I keep bringing that up. So inside here, you would say, okay, well, it's a -2. In this case, it's affecting the x. So that means it's moving left and right. So these are, when we have parentheses, we're talking about left and right, okay? So in this case, it's a -2. You would think you would go left 2 units because going left on a number line makes it smaller. But it's actually going to be a right 2 units. So let's see what happens here. Let's graph. So we have y equals 3x plus 1. Now, there's our graph. It's all fine and dandy. Remember, I had mentioned that we would think we are going left 2 units. We should be going right 2 units. So we should have, for example, this is where the y-intercept is. This graph should pass through right here. Let's see what happens. So we're going to substitute x minus 2 for x. Let me switch colors here. So we're going to do 3 times x minus 2 plus 1. So I just took this and substitute that there. So now we have 3x minus, minus 6 plus 1. So then we're left with 3x minus 5. So let's graph this guy and see what happens here. So y, whoopsies, what happened here? Minus 5. There it is. So you can see here that this was a shift or a slide to the right 2 units. And again, this minus 2 tells you that it's going right 2 units. And we know it's right 2 units because of the parentheses. A little bit tricky, ladies and gentlemen. All right, here's another tricky one. I'm not going to worry about, solving anything. I see this inside the parentheses. Inside is opposite of what you think it is. Because it's opposite, you would think that you would be going to the right 3 units, but instead you're going to go left 3 units. So let's see what happens here. Let's graph it. Let me actually erase this here. We don't need that there yet. Let's graph. All right, so here's our first equation, y equals x minus 5. So let's graph the other. Well, I need to create it first. So let's see. I'm going to substitute this for x. So then it would be x plus 3 minus 5. Oh, no, wait. Yep, minus 5. So then it becomes x minus 2. So if my estimation is correct, I would be going to the... what's going on here? I would be going left 3 units. So let's see. 1, 2, 3. So here would be where our graph should intersect. Let's see what happens. So there we are. It should have been, I don't know why it erased. I guess I am not very tech savvy. So this should have been x plus 3 minus 5. So then it would have been x plus 3 minus 5, which is x minus 2, which is where that equation came from. And it did pass where we wanted to. So this is a left 3 units. So again, when there's parentheses involved, it's the x that is affected. All right, so what we have here is kind of like a legend. This right here is like a breakdown of all the different parts of an equation. Today we talked about h and k. So let's talk about the h first. It's inside the parentheses. So because it's inside, it's opposite of what you think. So if you're going to be moving left anywhere, it's going to be a positive, or you're adding the number. If you're moving to the right, you're going to be subtracting that value. Now, while we talk about k, k is exactly what you think. So you're going to go up if you're adding, and you're going to go down if you're subtracting, okay? So in these two cases, h is the tricky one, k is exactly what you think it should be.